Hello my dear PU2 champions, how are you all? I hope you all are doing amazing. This is your Ekta ma'am here. In this video, we will be discussing about the PU2 fixed questions of 3 marks. Yes, these questions from each chapter will be coming in your chemistry exam for 3 marks. So do not skip these questions. Revise them, learn about them, revise them. Okay. Now obviously this is the revision period, not learning period. But somehow if you are not able to answer some of the questions, do learn them. Okay. So revise them properly with Shiny ma'am. Yes, she's working very hard for you. Right. So let's see what are these 3 marker questions are. So first of all, we'll start from chapter solutions, the first chapter. From solutions, we have these questions. I'll slide by so that you can take a screenshot of these questions. Differentiate between ideal, non-ideal solution, positive, negative deviation from Raoult's law, maximum and minimum boiling azeotrops, Henry law and its application, Raoult's law, right? These all questions are very important. They are coming as 3 marker questions. See? 3 marker questions. Okay. Now from the chapter chemical kinetics, these are the important questions. We have Arrhenius equation. What are the state symbol? Okay. So you just take a screenshot, my dear students. Yes. Explain the effects of catalyst in rate of reaction without proper energy, with the proper energy profile diagram. Yes. That energy diagram, that reaction coordinate versus diagram, that is very important. Okay. Explain the role of activated complex in the reaction. And then again you have the Maxwell-Boltzmann distribution curve. Then you have the Arrhenius theory. Explain the Arrhenius theory and the factors affecting the rate of reaction. What are some factors that affect the rate of a reaction? Okay. In electrochemistry, from the chapter electrochemistry, okay, we have graph between lambda m and root ski, right, for weak as well as strong electrolyte. Explain the limiting molar conductivity. Then you have Faraday's second law of electrolysis, anodic cathodic reactions of dry cells. Explain the role of produced ammonia. These all come as 3 marker questions. Okay. Now neat then label diagram of fuel cell, right? Hydrogen oxygen fuel cell, anodic and cathodic reactions, rusting of iron is an electrochemical phenomena. Question will come straight from this, because you see, my dear students, this question, explain the construction of standard hydrogen electrode. This question has been coming from 2014, 15, 17, 19. Every year it's getting repeated, right? And some questions do get repeated. So plan accordingly, and yes, focus on these questions which are getting repeated every year, because in one way or other, either they just change the language and ask the question, they will come in your exam. There are more questions. Karl-Roche law, that is very important. Then you have 2 applications of Karl-Roche law. Again, these may come in a combined form, and you have a cathodic anodic reaction of lead storage battery, discharge equation and the recharge equation. Okay, that is very important. Then from D and F block, yes, from D and F block, see this question, this gets repeated every year. The reaction you have, right, the manufacturing of potassium dichromate, the manufacturing of potassium permanganate, state questions are coming, right? This question is getting repeating each year. 16, 15, 18, 19, 19, 22. Right? So focus on this. I know there's some problem with this. So for balancing, I would say just remember this one reaction is there, right? In inorganic, you just remember the balancing and all, because it's a little difficult and time consuming. In exam, you want to save your time. Okay, so focus on time, effectively managing your time and smart work rather than doing the hard work. You have these 2 reactions, remember them. Memorize the balance stoichiometric coefficients also, right? So that you do not have to worry about it. Lanthanoid contraction is very important. These questions come in 3 marker, all these 3 parts will be there. Okay, so focus on that. What is lanthanoid contraction? What is the cause of lanthanoid contraction? Right, any 2 consequences of lanthanoid contraction, right? Then from then you have the reaction, these balanced chemical reactions. Individually they might come as 2 marker, but combined they'll come as 3 markers only. Explain the structure of Mn2CO2. Then you have explain the structure of iron carbonyl also, the carbonyl compound that is formed by iron, FeCO5, metal carbonyl, iron carbonyl, right? And then explain the structure of, again I've added them, right? Then from coordination compounds, yeah, it's a very lengthy chapter, right? But very easy questions are coming from it. You can predict also. So you have postulates of Werner theory, they are very important. The geometrical isomers of all these structures. With examples, you define all these type of isomerisms, ligands, homoleptic, heteroleptic complexes. Then you have synergy bond in metal carbonyls. Postulates of Werner theory again. Okay, so these questions get repeated every year. Okay. Then you have limitation of CFT, limitations of VBT, right? That is very important. Then d orbital splitting is also very important, right? For octahedral as well as for tetrahedral complexes. Then hybridization, magnetic property and geometry of these compounds. Again, these questions get repeated every year, so focus on these questions, okay? Revise them correctly, okay? Make these questions your priority. Next, from biomolecules, we have these questions about hormones, the essential amino acids, structure of sucrose, maltose and lactose, right? Denaturation of protein. What is denaturation of protein, right? And which level remains intact during denaturation? Then how many type of proteins are there? We have how many structure of proteins are there, right? Primary, secondary, tertiary. Then you have reducing, non-reducing sugars and anomers, apomers, invert sugar, right? Peptide linkages. From haloalkanes and haloarenes, the 3 marker questions that are going to come are these reactions, named reactions. Woods reaction, Finkelstein reaction, Sandmeyer reaction, Swartz reaction, Fittig reaction. These are very important. Setzeff rule, again, very important. SN2, SN1 mechanism. Yes, one question comes from this every year, so focus on that. Then you have aryl halides are less reactive towards nucleophilic substitution reactions. Freons, what is freons? What are freons, right? Then from alcohols, phenols and ethers. Now some of you might have some problem with organic because it is a bit terrifying. I know that, right? So don't worry. If you prioritize these questions, if you focus on these questions, your 3 marks are not going anywhere. Yes, okay? So what are the questions? Kolbe reaction, Ringmer-Reimer reaction. See, this question gets repeated every year. Kolbe reaction and how do you convert salicylic acid? Phenol to salicylic acid by Kolbe reaction. Straight question, okay? Catalytic hydrogenation of alkenes, very easy. Dehydration of alcohols, formation of ethers. So prioritize these reactions. Focus on them first and then do other reactions, okay? But do not skip this at all. Next, from aldehydes, ketones and carboxylic acid, we have these questions. Helmholtz-Zielinski reaction, HVZ reaction, that is very important. Mechanism for the addition of HCN to carbonyl compound in the presence of base. Aromatic carboxylic acid does not undergo Friedel-Crafts reaction, give reasons. Between methanol and ethanol, which would undergo aldol condensation. Yes, that is very important. These questions, these type of questions involving aldol condensation, right? And what are the conditions for aldol, for Cannizzaro and all, okay? Now, next, how do you prepare phthalimide from aromatic dicarboxylic acid? This is a very big question. So, this won't be coming as 3 marker. It will come as 5 marker. 3 plus 2, right? So, again, take a screenshot, practice these questions. Shiny ma'am has solved all these questions in her life. So, go there, check it, okay? Then from amines chapter, we have how do you distinguish these between primary, secondary, tertiary amine using Hinsberg reagent, right? And what is Hinsberg reagent? And again, and how do you distinguish between primary, secondary and tertiary amines using Hinsberg reagent? Then explain Carbonyl amine reaction, explain the basicity of order of amines in aqueous and in gaseous phase. That is very important. Now, that was all. All the 3 markers I have covered, and these are all the important 3 markers. Most of them, I am going to bet you are going to see most of them in your boards. Okay, so do not worry. You got it. All the best for you.